This here is Trace, the second generation flight computer for my thrust vector controlled rocket. This was my first real PCB, so I gave it a name to reflect that. It has already flown on both TVC flights and will be flying on Flight 3. First, I'll go over its specs and hardware, then I'll go over the software it runs. The flight computer's central microcontroller is the Raspberry Pi Pico, but is upgradable to Raspberry Pi Pico 2 if needed. To measure its orientation, the computer needs an IMU, and for that, I use the MPU 6050 and left it upgradable to a BNO 055. The MPU 6050 was used for both flights so far, but all future flights will use the BNO 055. To measure altitude, the computer uses a barometric pressure sensor, specifically the BMP 280. It uses a microSD card for data logging and can include a flash card for the system, although I've been unable to get the microSD card and flash SD card working at the same time. For external state indication, it uses an RGB LED and a 5-volt buzzer. The computer includes 3 power channels for in-flight events and can run off a 9-volt battery or 3-cell LiPo. Lastly, the computer is able to drive a reaction wheel with an L293D dual H-bridge motor driver. The software the computer runs is state-based, which means it prioritizes different functions depending on what stage of flight the rocket is in. It boots up to red, and if it stays red for over 5 seconds, that means that there's an SD card error. Then it'll turn magenta, which means that it's calibrating the IMU. After 10 seconds, it'll enter blue, which means it's pad idle. Here, it's waiting for a vertical acceleration of over 12 meters per second to detect launch. It's also constantly recalibrating the altimeter and orientation system using gravity as a reference point. After the acceleration trigger enters flight mode, where the orientation measurement system switches exclusively to gyroscopes. It's also running the TVC mount's PID loop, as well as recording high-speed data. When the acceleration is first negative, it means that the air is pushing back on the rocket harder than the motor, meaning that burnout has been reached. During burnout, the computer is looking for a decrease in altitude to signify apogee. At apogee, the computer fires power channel 1 to deploy parachutes. So that's pretty much all I have for Trace so far, and I'm excited to have it fly on Flight 3. Thanks for watching.